Welcome to our lesson video for day 3B.3. Today we're going to be talking about two more unique quadrilaterals, and that's called a rhombus and a square. And when we talk about what a rhombus is, the plural of the word rhombus is the word rhombi. And so when you see me say rhombi, that just means more than one rhombus. And so we're going to be talking about these two unique quadrilaterals again, but you do need to understand this first. And the first thing you want to understand about a rhombus is that it is a special kind of parallelogram. So all the properties of parallelograms do apply to a rhombus. Or all parallelogram properties apply to rhombi. Now, beyond that, though, there are several unique characteristics of a rhombus that we're going to look at. Okay, and here's the first unique property of rhombi. And that is that there are four congruent sides. And since there are four congruent sides, all four sides are congruent, we could mark it like this with the same tick marks on all four sides. They're all the same length. AB is congruent to BC, which is also congruent to CD, which is also congruent to AD. Okay, now we have some other unique characteristics of a rhombus, and we're going to look at those now. And those deal with the diagonals. So I'm going to draw in the diagonals and help you understand some things about these diagonals. The first is that the diagonals are actually perpendicular. Okay, the diagonals are perpendicular. And so as we look at this, with the diagonals being perpendicular, that means they intersect at right angles to one another. So we can mark it just with one right angle box, okay? Okay, we have one more thing we need to know about diagonals, and that is that the diagonals bisect opposite angles. And that tells me that this angle at A is congruent to the other angle at A, and this angle at C is congruent to the other angle at C. And because opposite angles are congruent, and we've split congruent angles in half, that means all four of those are the same. And then similarly, these two angles at D are the same as these two angles at B. So all four of those little pieces are congruent, and that's how we can mark that. And so as we move forward, we are looking now at one more key idea that is going to be useful to us, and that is this. Since the diagonals are perpendicular, we know that these diagonals create four congruent right triangles. These four triangles created by these diagonals are congruent to each other, and they're all right triangles, so we know things like a squared plus b squared equals c squared. We might need to use that in certain problems that we do problem solving with. So we're going to use these characteristics to identify some measures and solve some equations regarding a rhombus or rhombi. So let's take a look here at number one. As we look at this, this is a rhombus. Every problem we're given here, we can assume it's a rhombus. And they just want all the angle measures. Well, there's one angle measure they give you right here. We know that is a 38-degree angle measure. All of the other angle measures are going to be related to that based on what we know about a rhombus. Okay. First of all, diagonals bisect opposite angles. So angle 3 is also 38, and angles 4 and 5 are also 38 as well. All four of these angles are going to be the same. So I know the measure of angle 3 is 38 degrees. The measure of angle 4 and 5 are both 38 degrees as well. Okay? Now, we know some other things about the diagonals of a rhombus, and that is that they are perpendicular. And since they're perpendicular, that means this angle 8 here on the inside where they intersect is a 90-degree angle, because we know all those are right angles. Okay? Well, now remember, we also have right triangles, or four individual triangles. And so what I want you to focus on is this right triangle here. And you might remember from the previous lesson that the acute angles in a right triangle are complementary. which means they add up to 90 degrees. So in order to find the measure of angle 7 here, we're going to do 90 minus 38. And when I do 90 minus 38, that gets me 52 degrees. So the measure of angle 7 is 52 degrees. But remember, we have these angles here and here that all four are going to be the same value. So I know the measure of angle 6 is 52 degrees. I know the measure of angle 2 and 1 are also 52 degrees. So there's all the pieces or those angles that I'm looking for in this problem. Okay. Now, as we look at number 2, we've got MNOP is a rhombus, and they want you to find the length of MP. And again, we are going to use a property from that list, either a property of a rhombus or could be a property of a parallelogram, to find this length of MP. Now, MP is this side. Okay, they only give me these two sides, MN and PO. But remember, all four sides of a rhombus are congruent. So the property we're using is this, that there are four congruent sides. I'll put it where you can see it. Four congruent sides, that's our property. And so since we're using four congruent sides, we can set this up to where these values are equal and plug in for our value of x, and it gives me the same thing. So all I have to do is plug into one of them. So I chose MN. But the first thing you're going to do is set these equal to each other. 9x minus 77 has to equal 3x plus 7. And then we can solve that for x. And we get x should equal 14. When I do 84 divided by 6, that's 14. And as we move forward then, we need to plug back in, like I said, to one of those two expressions. I'm going to choose the top one. 9 times 14 minus 77. Okay, when we do 9 times 14, that is 126. And when I do 126 minus 77, I get 49 in length. And this is not degrees because we found a length of a side. So that length would be 49. Okay, let's keep moving. Looking at number 3, again, we're assuming this is a rhombus. And this time they give you the measure of two angles, SUT and RTU. SUT, or I could call it VUT, meaning the same angle, and RTU. RTU is this angle, is what they want me to find. Okay, in order to do that, I'm going to use four right triangles again. That's one property I'm going to use. But first, I'm going to use the property that the diagonals bisect opposite angles. Okay. Okay, that's my property. Diagonals bisect opposite angles. So now I'm going to set up an equation to solve this. Since I'm bisecting this angle at U, these are equal values to one another. So I can say 10x minus 23 equals 3x plus 19. And so we are going to subtract the 3x from both sides, and that gives us 7x minus 23 equals 19. And then we add 23 to both sides. 23 plus 19 is 42. And then we divide by 7 on both sides, and x is 6. Now, to actually solve the problem, this is where it gets a little more tricky. We want to go back in and find both of these angles. Well, one of these, okay, measure of angle, SUT, I'm just going to plug in, okay? I'm going to do 3 times 6 plus 19. 3 times 6 is 18. 18 plus 19 is 37. Okay? Now, to find the other angle measure, the measure of angle they ask for RTU, we are going to remember that that's a right angle and that these other two angles of that little right triangle add up to 90. So all I have to do is 90 minus 37, and I get 53 degrees. So there's the two angle measures I was asked to find, and that finishes that problem. Okay, here's what I want you to do. Okay, this one is a review a little bit of something we've done before. It says that ABCD forms a rhombus. For number 4 here, we are given only 2 coordinates. From those 2 coordinates, we should be able to find the length of AB. All right, and then it asks for the perimeter of the rhombus. Well, remember that perimeter is the sum of all 4 sides. Okay, so it's AB plus BC plus CD plus AD. However, all 4 sides are congruent in a rhombus. 4 congruent sides. So all I have to do for this problem is do 4 times the length of AB. So what I want you to do, I want you to go ahead and find the length of AB using the distance formula, and then multiply it by 4 and give me your answer. Pause the video to give yourself enough time to do this. All right, if you have this filled out, this should be the answer you get. The perimeter should be 20. Now, go back to look at my work for the length of AB. We should get a length of each side of being 5 units long for that rhombus. And so when we do 4 times 5, or 5 plus 5 plus 5 plus 5, that gives us 20. All right, let's continue right along, and let's look at our final special quadrilateral, and those are squares. Now, here's the unique thing we can say about squares. A square is simply the combination of a rhombus and a rectangle. So here's all I want you to write down for our properties of a square. All parallelogram properties apply to squares. All rectangle properties apply to squares. All rhombus properties apply to squares. Those are the only characteristics we need to write down because we already have those listed out previously in the notes. Okay, so all of these properties of a rhombus will apply to squares. 4 congruent sides, diagonals perpendicular, diagonals bisect opposite angles, diagonals create 4 congruent right angles or right triangles. Okay, from rectangles, all the properties of parallelograms still apply, but also for right angles, diagonals are congruent. And then again, remember, in any right triangle, the acute angles are complementary. And finally, all those properties of parallelograms, parallel sides, congruent opposite sides, opposite angles, congruent, so on and so forth. And actually, we get a very unique set of classifications for a square. For a square, since basically it has all of these unique properties, we really get that this is a regular quadrilateral. It is equiangular and equilateral, which makes it a regular polygon. So we have these unique characteristics. We have 4 right angles, 4 congruent and parallel sides. I'm just going to mark some of the basics. Okay, and as soon as you mark that, that is enough unique information to make this a square. 4 right angles, 4 pairs of congruent opposite sides, or all sides congruent, rather, makes it both a rhombus and a rectangle. Okay, and that makes these squares. So we're going to use all of these properties in these problems. Okay, so number 5 here, the first one, if STUV is a square with SW being 2x plus 13, you can even write it in if you want, and WU being 8x minus 41, find the length of VT. We're using the diagonals of this square, so we want to remember what we know about diagonals of rectangles and rhombus. Okay, diagonals of a rhombus are perpendicular. That tells you more about the angles, not as much about the sides. Bisect opposite angles, same thing, tells you about angles. So we want to go back and look at properties of something else. Properties of a rectangle for diagonals, the diagonals are congruent. That is going to help me a little bit, but the main idea that we're using is that the diagonals bisect each other. Okay, we're using this main idea, number 5 here, our fifth one from parallelograms, is the diagonals bisect each other. Okay, so that's our property we're going to write down. Okay, so the diagonals bisect each other. Remember, that means that these are congruent pieces. And since it's a rectangle, all 4 of these would be congruent. So VT is really just the length of twice either one of those, SW or WU. So once we know what X is, we can plug into either one of those and get the full length of that diagonal, because VT is the same as the full length SU. So first we set these equal to each other. 2x plus 13 must equal 8x minus 41. Subtract 2x from both sides. You get 13 equals 6x minus 41. Add 41 to both sides. You get 54 equals 6x. Divide by 6 on both sides, and x is 9. And so as we look at that, we are going to plug back in 9 for both of these. So we're going to do 2 times 9 plus 13 and double that, or go ahead and do 8 times 9 minus 41 and add those together. Either way, you should get the same thing. So our final answer for VT is going to be 2 times 9, which is 18. 18 plus 13 is 31. So that length is 31, and that length is 31. If I add those together or double it, I get VT is 62. Okay, let's keep going. Okay, if I'm going too fast at any point, remember, pause the video, copy things down, make sure you understand, jot down any questions you have about these. Okay, all right, next. FGHI is a square. We're going to solve for X here. Here's the unique thing about this. The property we're using 2 of them. Okay, we're using the diagonals are bisecting opposite angles. Bisect opposite angles. And we're using the fact that there are 4 right angles. That means in any square, the diagonal creates half of 90 degrees at each of these corners, making these all 45-degree angles. You can write them all in. You don't have to write them all in, though. So that means this expression equals 45. So we're going to go ahead and do 7x plus 3 equals 45, and just solve for x this time. Minus 3 from both sides, 7x is 42. Divide by 7 on both sides, and x is 6. Okay? All right, just a little bit further. And in fact, this next problem is even more simple than the last one. All you're doing is finding given angle measures, but there's really only 2 different angle measures we could have, either 90 degrees or 45 degrees. And it's all about figuring out which ones are which. All of these acute angles are 45 degrees, like that. They add up to 90 degrees, and then the intersection of the diagonals are 90 degrees. So when it says angle PRS, PRS is this angle here, that's 45 degrees. When it says angle STR, STR, that's that angle, that's 90. PSR is another right angle at the corner of the square. And QPR is another 45-degree angle. It's this one here. Okay? All right, one final example. All right. Triangle, or ABCD forms a square, not a triangle, square. And we're given 2 points again. This time they ask for the perimeter and area. Well, we've done perimeter already, very similar to what we just did for a rhombus. I'm going to have you pause the video, find the perimeter again. Remember, it's just going to be 4 times the length of that one side. I'm going to find AB first. Okay. And then the perimeter is just 4 times that length. Then I'm going to find area. And I need you to remember that the area of any rectangle is length times width. Okay. But for a square, we don't call them length and width because they're the same measure. We call it side length, S. So I take S times S, or S squared. That's why we call something to the second power squared. It's like finding the area of a square. So what we're going to do is that S is a side length. All right, so that's just our whatever length AB was. We're going to square that, and that's how we're going to find the area. So it's like 2 problems in one here. So again, pause the video, use your distance formula to find the length of AB, and then see if you can find the perimeter and area. If you still need more time, keep the video paused here. Otherwise, this is what we should get. The perimeter should be 52 because with our distance formula, we get the length of AB is 13 exactly. When I do that times 4, I get 52. And then I take that 13 again and I square it for my area, 13 times 13, and I get 169 again. So that is how we can use distance formula, again, even with our properties of rectangles, rhombi, and squares. Now you'll see down here in the notes, it does say there's a quiz next class. Okay, with that quiz, that'll be after you have completed this 3B.3 lesson. And so you'll need all 3 of these lessons, 3B1, 3B2, and 3B3. Make sure those are done before the time of the quiz so that you are prepared and ready.